including for the development of improved varieties, particularly in Indian jujube or Indian ber and mulberry. And also SAR formulated the dust guidelines for the Indian jujube and advancements in the micro propagation and biogardening techniques for the horticulture crops. And also SAR has made significant academic contributions through a number of research publications and books in the national and international publications. And also SAR contributed as an editor for the vocational course in horticulture, particularly under the CBSE syllabus, and served as editorial boards for reputed horticultural journals. And also for his achievements, he has been recognized for several prestigious awards, including Dr. R.D. Asana Gold Medal Award and Certificate for Excellence in Reviewing from the Scientia Horticulture. And also SAR is the fellow of Indian Academy of Horticulture Science and National Academy of Biological Science and Indian Society of Arid Horticulture. And with these brief introductions, I warmly welcome you, sir, and request you to kindly deliver your lecture. Thank you.
Thank you, Dr. Silva, for such a nice introduction, and also I'm thankful to you and all your team and organizers for giving me this opportunity to interact with your participants, which have joined through, who have come to different parts of the country. So thank you so much, Dr. Silva, for giving me this platform. And also I would like to tell, as Dr. Silva has already spoken about me, that I previously worked in fruit crops, and since 2018 I started working in vegetable crops. So it has been a new experience, altogether a new kind of experience for me. So I'll be here presenting whatever I learned from through my this tenure from 18 to 26, which I'll be sharing with you. So if something you find missing, so please forgive me, because I'm also a learner. I'm also a learner in this vegetable field, but I'll try my best, whatever I have learned, to convey it to you. Okay. So with these words, I'll now straightway go to my presentation, which is on LED effect on plants and crop growth stages based nutrient scheduling in tomato. So basically there are two themes. One is the LED effect on the plants, and another is a crop growth stage based nutrient scheduling in tomato. So first we will start with the how this LED manipulation is required for having a good quality yield in protected cultivation. So for as a background, I would like to say that we all know that this vegetable demand and urbanization both are increasing together. And if we see that by the end of the year 2050, when more than 50% of the more than 50% of the Indian population will be residing in the cities, we'll be requiring more than 320 million tons of vegetables. But we all know that land is very limited. We cannot increase the land. Though population and vegetable demand is increasing, but we cannot increase the land. That is fixed. And other than that, also we have several factors like groundwater over extraction, especially in urban areas, then lack of water recycling and reuse, and the climate change. So these all factors actually they compound, they make it very complex to go for a cultivation of agriculture crops. Further, this factor has led to situation like day zero. You know, day zero situation when there was no water in major metro cities like Delhi, Bangalore, Chennai, Mumbai, and Hyderabad. So when we don't have water, but we will be having more than 50% of our population residing in the cities by 2050, how can we will be able to cater their demand? So that's a big question. Secondly, we often come across the reports of contamination of harmful pesticides or toxic chemicals in vegetables. These are very often we see such reports. So these actually again they are very alarming from our health point of view. So this actually necessitates that we should look for some alternatives so that we can have a safe food within the urban premises. So what could be the better way for urban farming, and that too in a safest way? So one way is to have safest food production in urban areas is vertical farming, which is actually defined as a cultivating and producing crops in a vertically stacked layers and vertically inclined surfaces. So now coming to the what are the key benefits of this vertical farming? As we all know that it can meet the demands for vegetables within the urban limits, and it is the foods which are produced within the through this vertical farming are considered safe food. Then it also mitigates the production losses from urban land shortage, and there is a tremendous water saving. That is only 0.3 to 5% of total system water is used, because we always use recycling of water is done, and it requires very low compared to the soil cultivation. It requires low fertilizers. So so other than these benefits, now we will come to how this light effects affects the growth and yield of the our crop in a hydroponic system or vertical farming system. So why this light is important? Why it is crucial? So because there are the reasons. One is that in vertical farming we grow the plants in a vertically stacked structure. So there is a shading there because they are stacked. So there is a shading from the top portion. So that is why, and it is also vertical farming is also sunlight dependent. It is not on sunlight dependent. We usually do vertical farming in enclosed areas. So sunlight cannot come. We have to provide artificial light, and if you are providing artificial light, they cannot penetrate very well within the each layers of the canopy. Then similarly, since it's a protected cultivation form, so we go for a higher planting density. So what happens when we are going for higher planting density? The top portion is receiving the ample light, but the lower portion of the plant or lower leaves of the plant, they are not able to get the good light. So that is why the quality and yield both are compromised if we do not take care of the light quality and light amount. So that is why this lighting is very important. It has become very important for having a good quality produce from vertical farming. So now we will come to the different spectra of light, because each light is having different spectra, and each spectra has its own role. Like blue light, which actually ranges between 400 to 500 nanometer. It regulates stomatal opening, it enhances chlorophyll, and also it is very much responsible for the compact canopy architecture. That's a very important thing with the blue light. Similarly, then there is a green light which ranges between 500 to 570 nanometer, and green light, what it does, it helps penetrating deeper into the canopy, and thereby it improves the photosynthesis in the lower leaves where usually the light doesn't reach. So this green light has this important role. Then there is a red light which has a 600 to 700 nanometer wavelength, and we all know this red light is very important for flowering and canopy development. And then there is a far red, that is beyond 700 nanometer. This is considered far red light, and we know this red far red ratio, this phytochrome, these are very much important for inducing flowering in and fruiting in crops. So we'll be dealing in details in our coming slides. So now, like animals, most of the animals, they have eyes. So through eyes, we actually see our environment, in what kind of environment we are. Whether it's a threat to us, there is threat to us, or something which is good with us. So through eyes, our eyes, we recognize the things. But plants, they doesn't have they don't have eyes, but they actually sense the light, and they have very advanced sensors, this plant sensor, and these plant sensors are called as photoreceptors. This sensors are photoreceptors, and they are classified into different types, like phytochrome is there, cryptochrome and phototropins, and then UVR8 receptor. So each have their each role. For example, plant is in under shade, then it will sense that through this photoreceptor, it would sense that there is not ample light. So what I need to do? Similarly, when there is ample sunlight, it will also sense that there is ample sunlight and the desired wavelength of light is there. Then should I need to flower? Should I need to elongate? Should I need to put forth more vegetative growth? These all are done through these photoreceptors. So the first one is a phytochrome, and this phytochrome, we all know, we have already studied. There is a PR and the PFR form, far red and red for red. So this PR is a inactive form, and when red light falls upon it, this PR get into the activated form, that is PFR form. So PFR form, this far red form, is actually responsible for flowering. So we all know this PR to PFR conversion. And then there are cryptochromes are there, and phototropins. They are the photoreceptors, especially for this blue light. And their primary function is chloroplast movement and stomatal opening. And as I already discussed, this compact growth habit is very much influenced by this blue light. Similarly, to send this UVB light, there is a photoreceptor which is called UVR8. So this is actually responsible for triggering the defense mechanism or stress response, and also it is responsible for flavonoid production. Since it is related to defense response, so there are many antioxidant enzymes are synthesized in response to UVB light, and this we are well aware that this antioxidant enzymes are considered good for our health. So thereby indirectly, if there is a UVB light in a mild amount, then it would boost the nutrient quality of the produce. So this way actually light has different function. So if we are now we are aware that what red light does, what blue light does, what green light does, how UVB light affects. So we have now become aware of all the kind of light. So if we are what is our intention? What is our aim? So with that aim, we can, through this LED light, we can achieve it. What kind of growth we want, we can put that kind of light. Suppose we want early flowering, we can put far red light. If we want compact growth, we can put blue light. If we want more nutrient content, we can go for mild UV light. So this way we have now understand it, and now we can, as per our need, we can modify it. So here comes the picture of LED light. So with by placing the proper number of and proper quantity of LED light, we can manipulate plant growth and yield and quality as well. So all this, not all crop have the same requirement. It actually depends. Like if it is a leafy green, then for better growth of leafy greens, we need high blue light and high red light. If blue and red both are high, usually then leafy green growth is good. Then for herbs, if we are going for herbs cultivation, then they require a balanced amount of both blue, red and green. All the three in the balanced amount. So it gives a best result. Similarly, if you are going for fruiting crops like tomato, capsicum, then for that we need red plus far red light. We already know this phytochrome is there. So because of that, we need red and far red light in a proper condition. And similarly, if you are going for a microgreen, so because microgreen we require small stretched microgreens are actually preferred. So that is why we need compact growth. So for that, we go for blue light at initial stage and then red light at later stage, because red light triggers some other qualities in the crop. So that's why initially blue light and then at later stage it's a red light. And even their light requirement actually varies according to stage as well. For example, when it is at seedling stage, then seedling, we don't want lanky seedling. We would always would like to have a sturdy seedling. So for that compact growth, compact and sturdy seedling development, we go for higher concentration of blue light. So you need to place more blue light when the plants are at seedling stage, so that you get a sturdy, a strong seedling. Then once it is in vegetative stage, so that time you have to have a balanced amount of both red and blue light, so that there is a quick biomass accumulation, so that plant completes its vegetative life cycle in time. And then when it comes to the reproductive stage, then again this red and far red light combination comes into effect, because it's a responsible for conversion of phytochromes into from PR to PFR form, that leads to the flowering and then ultimately to fruit development. So this is a stage-wise requirement of light. Similarly, as we already initially in introduction we discussed that in vertical farming we go for a dense canopy. And in dense canopy, what happens? Top leaves receive the ample amount of light, while the lower leaves, they do not get that sufficient light. So in want of that sufficient light, their quality is not up to the mark. So to make it more acceptable, the whole lot to make whole lot more acceptable, we have to make some other changes. So what changes we need to do? We have to go for a green light, because this green light is having capacity to penetrate deeper into the where the lower leaves are there, where other forms of light doesn't reach it. And also we need to enhance the far red light, because this far red light actually modifies the canopy angle. So if leaf angles improve, so more light actually falls onto the lower leaf. So the green light, so by putting more green light and far red light, we can improve the light interception under dense canopy culture. So with this, with this modification, we can go for have a good quality of produce from the whole lot. Then there are some disadvantages also, like it has to be balanced one. It should not go to the extreme one. If you are thinking that something benefits us, we should put it more. No. If you are putting more, then there are some, it comes with some disadvantages as well. Like red light is good, but if it is in excess, then what happens? The internodal length increases, which is not, if it is a too lanky growth, it is not desirable. And because its plants become the soft also, so that's a not, it's a visual appeal also goes down, and the overall quality also diminishes. Similarly, if you are putting excess blue light, which is known for, this blue light is known for a compact growth. If plant is too compact and it has a too dark green leaf, then again yield reduces, because we need some biomass also. So if it is too compact, then biomass will be reduced. So that way also we should not go for excess blue light. Similarly, even if there is a excess far red light, then again there is a problem, because in case of excess far red light, the leaves become large. And if there is a large leaf, usually we know that that when volume or size increases, there is some dilution effect work. So the pigment content actually decreases. Leaf enlarges, but the pigment within that decreases. This pigment, carotenoid and chlorophyll, if they diminishes, it means the quality of the leafy vegetable will go down. So that also we need to avoid it. So we have to put that balance amount. And it is not like you are putting one strip of red light, one blue light, and one green light. It is sufficient. It actually, you need to work this one through experimentation, because it's not only up to the crop. It is even from variety to variety, this requirement will actually differ. So that we need to do by our research, that how much light per unit area we have to put from each spectrum. So if from nutritional point of view, if you see that how this light quality affects, so we see that this blue light actually enhances phenolic compounds, flavonoids, anthocyanin, and antioxidant content. Similarly, this red light increases carbolic compounds in the plant. That also is a kind of, it improves the antioxidant activity, and it also increases fresh red light. And while the far red light, it increases actually total biomass, so the yield increases. And but as I said, if there is too much of far red light, then it may reduce your nutrient content due to the dilution effect. So there is a, what we learned, that there is a no universal best spectrum. We need to work out for species also. For each crop species, we need to work it separately, and it may vary from variety to variety, as I have already said it. And this even we have seen that even across the growth stages, the requirement of light varies. Initial blue light, then red blue, then red and far red. So as the crop requirement changes as per with the changing growth stages, we need to change the this position and amount of this LED light. So through this way we have to do, and also this light manipulation depends upon what is our goal. Suppose our goal is more biomass, not the quality, then we should go for far red light mode. But if our aim is to go for a higher nutrient content, then blue and red we should go for, because this blue and red combination together, they improve the most of the compound, most of the this antioxidant compound, they increase. So what is our goal? That also we need to keep in our mind when we are going for putting LED lights in a vertical hydroponic system. And if we know that what light is required at what stage, then we need to only put on that light on, because in your vertical structure, you need to place all kind of LED light like red, blue, green, red, far red, all. But you need not to put on all together, because you now by this time we know that not all the light spectrum is required at all the crop growth stages. So as per the growth stage requirement, we need to put on only those kind of light which is required at particular stage. So by that we can actually save the energy also, and also by manipulating LED light we can shorten the crop cycle and improve the yield and quality as well. So now I will show some of the slides pertaining to what I have done at my place. We had one aquaponic structure. It's a hydroponic plus fish unit. So here, but fish is another component, but here mostly you should consider as a hydroponic NFT structure. So here we have gone for two crops. One was pak choi and another was a lettuce. And we have put red light, then we have put only blue light, and then combination of red and blue light, and another was control. Control means it was getting natural sunlight only during daytime. So what we saw that it has a tremendous effect. Like we didn't see much effect on this physiological weight loss, but as per in terms of this antioxidant or vitamins content, we saw there was a huge difference. And in most of the time we saw that whenever there is a red blue light together, we got better result. Otherwise, red light alone is good for improving many things like flavonoid. Red light is coming more. But if you are going for ascorbic acid, we'll see blue light is performing well. But overall, when for a total antioxidant capacity, we saw that this when we are putting a combination of red light and blue light, we got the best result. And similarly, say same kind of trend with little variation, we saw the trend in the lettuce also, and we have gone for microgreen production also. So in that also we saw that this light influences the quality of microgreen of amaranth and palak. So, by manipulating this light spectrum, actually we can, without adding additional input in terms of micronutrient or some other growth regulator, we can improve the quality. So, so far this light has not been the LED light or light spectrum role in the in a hydroponic system or vertical farming system has not been given due attention. But now researchers and growers are realizing its importance. So sooner or later, it will be followed everywhere that whenever you are going for a quality production, we have to put provision for the LED lights. So we have already discussed many things, and one limitation is that this if you are going for LED light, it would put extra cost because it consumes electricity. So for that, we propose that there should be a self-sustaining vertical farming system, especially in urban areas. For example, for whenever we are making buildings, I'm talking about the future, we cannot make changes now in the existing building, but at in future we don't have space. So I think we have to go for a production in urban areas only. Otherwise, we won't be able to get food. So for that food production within the urban areas, we'll have to make certain changes in our building structure itself. So we need to put the sun-facing side inclined so that it captures maximum sunlight. And we have to put LED light additionally to improve its quality or to manipulate its yield. So for that LED light, we need electricity. So how can we get electricity? This can come through the solar energy harvesting we have to install on the rooftop, and this energy will be stored here in the battery, and from that, when the solar battery is charged, that will be used during night for providing this light, red light or red, blue, green, whatever spectrum we want. Similarly, if you are going for a self-sustaining structure in urban area, as I told, there is a already water scarcity in most of the most of the metro cities. So to combat that problem also, we need to think that we should encourage recycling and natural harvesting of water. So for that, we need to install rainwater harvesters, and that water will actually get collected into the underground tanks. Similarly, whatever the water is used in kitchen or basins, in kitchen or that water is called as a grey water. We won't use toilet water because toilet water is considered as the black water. So no black water, only grey water. Grey water means the one which comes from the kitchen sink and the bathroom basins. So that water will get collected into the underground tank, where three kind of reactors will be there: anaerobic reactor, then anoxic reactor, and then again aerobic reactors. Through anaerobic, anoxic, and aerobic, the grey water becomes again for it becomes fit for again becomes fit for reuse. So that water again recirculated into this hydroponic structure. So with this, we can have a self-sustaining vertical model in our urban areas. So that's a future line of work we need to think upon. Similarly, now I'll come to my second part of my presentation. That's also what I did here. And you all know that in protected cultivation, it's a part of my research on protected cultivation of tomato, polyhouse tomato. And we all know this tomato is one of the most important crop which is grown in polyhouses, and it's a very much nutrient responsive crop. So many a times people give excess fertilizers. But what happens when we give excess fertilizer? This contaminate water. This contaminate groundwater. It promotes greenhouse gas emission, and also when there is a higher NPK, these macronutrients are more, then this imbalances the ratio of micronutrient, which is also required by the plant. So to avoid that one, we need to actually go for a precise use of nutrient. Like only that nutrient is to be given which is required and at particular growth stages. So for that we have gone for phenological the growth stage based fertigation technique in tomato, and for that we have identified different phases like seedling phase, then tree flowering or vegetative growth stage, then floral emergence stage, then flowering, then when fruits are at marble shape, then fruits has attained it's 90% of its size, a mature fruit, and then again it's a ripe fruit which is harvestable at harvestable stage. So we have identified this seven phenological stages, and we have then estimated this nutrient in at different stages of plant. So we found that initially this nitrogen was more in the plant while potash was lower. But as the plants went towards harvesting, we saw that nitrogen content decreased, but the potash content, especially in foods, it actually increased. So we have calculated this uptake of the different nutrients at different crop growth stages, and this is the this slide shows how the dynamic is there in the plant in as per the in terms of the nutrient uptake. So we can see here that nitrogen is second most requiring nutrient by the plant, then phosphorus is the least required, and during fruiting it's actually phosphorus. At mature fruit stage it is still higher than the nitrogen, but when it comes to the ripening stage its requirement is increased, is multifold, it gets increased. So this way we have found that at different phases how much percent of nitrogen, phosphorus and potash is required by the plant. Then we saw that 77% of nitrogen, almost 70 to 78% of the total nutrient is required during the 120 to 200 days after transplanting in polyhouse tomato. That is actually harvesting period, because in polyhouse tomato, this harvesting period is longer. So during these 80 days, plant actually almost 80% is uses its nutrient. And for ease of application, we have again these 7 phenophase were grouped into the 4 groups. One was seedling to transplant establishment and plant development, that is pre-flowering phase. So it comes 30 to 35 days after planting. Then floral initiation to fruit formation stage, that is 35 to 80 days. Then fruit formation to first harvest, and then first harvest to last harvest. So from agronomical point of view, we have made 4 different stages based on the phenological growth stages we have identified, and we found that plant removes 357 kg of nitrogen, 85 kg of phosphorus, and 527 kg of potash during its crop cycle. So again, then we converted this based on the nutrient use efficiency, like it's a nutrient requirement by the plants. But since we are using different fertilizer, so based on the fertilizer use efficiency for each nutrient like nitrogen, phosphorus, and potash, we have got it converted into the again got the corrected value. So it would claim in terms of nutrient use efficiency, we have to add 370 kg of nitrogen, 189 kg of phosphorus, and around 660 kg of potash. So We have also estimated different doses of fertilizer because we have estimated, so we have put its name estimated dose of fertilizer. Usually we coin the term recommended dose of fertilizer, but we coin the term estimated dose of fertilizer because based on nutrient uptake, we have decided, estimated it. So if you are having this 4 formulation for your fertigation scheduling, then we have made this chart, like how much nutrient will be required during different, this fertilizer will be required during various crop growth stages. So it would vary because if you are using to 19, 19, 19 or 20 all, then this calculation will change. But what I showed based on what I had, and based on that, we made one schedule also, weekly schedule, these 4 growth stages, and with that, how much has to be applied every week. So that schedule also we prepared. And since what we estimated, we called that estimated dose of fertilizer at 100%. But we are not sure if there are some other factors which are playing roles. So whether what we have estimated is it's a correct or it's a wrong. So for that we have gone for a 1 lower dose and 3 higher doses, 125, 150 and 175 based on what we estimated. We termed it as estimated dose of fertilizer at 100%. So, but what we found that 125% is actually is the best performing combination of NPK. So, if we are giving the 125% of what we have estimated, we have already shown. So, we found both this number of fruits, average number, average fruit weight, average fruit length, width and diameter, and yield. This was highest with the 125% of estimated dose of fertilizer. And this we can see at higher doses like 150% or 175%. We saw that because of the excess fertilization, that leaf margin, like at 150, we saw little leaf marginal necrosis. But in case of 170%, the nutrient toxicity was too much. So even chlorosis was also there, maybe because of nutrient imbalance. So this is why we recommend 125% EDF. And we found that though yield was higher, but quality was best when we gave lower little nutrient stress, and we all know that during stress, plant produces more antioxidant compound. So maybe because of that, we got at this when there is a mild stress, like at 75% EDF, we got the higher antioxidant activity. But with 125%, we got highest ascorbic acid content, while the rest of the things were just with the 75% EDF. So I would like to wind up my presentation by quoting the quote of late Dr. Swaminathan, Bharat Ratna Dr. Swaminathan: bringing agriculture, nutrition, and health together will make a major contribution to achieving the goal of freedom from malnutrition. We are now self-sufficient, but still we don't have a proper nutrient in our body. Also, we all are means in general our Indian population is having a malnutrition to a great extent. So by this proper nutrition to the plant, we can, pardon. So we can have a proper diet also, proper balanced food. So with this word, I thank you all, everyone, organizers, and you all participants for giving me a very patient hearing. Thank you.
Thank you, sir. Thank you for enlightening us.
Is there any
questions? Thank you for a wonderful presentation, sir.
Thank you so much. The session is open for the question answer session. Participants, you can ask the questions now.
Good evening, sir. Hello?
Yeah.
Hello. Am I audible, sir?
Yeah.
Yeah. First of all, good afternoon, sir. Thank you for giving us such a wonderful session. My question regarding